Hello, students, viewers. Today we are back with another video. Hey, it's your brother Edwin Klomo. We are back today. I decided to make a video on the quadratic function or the parabolic function. So the quadratic function of the parabolic function is determined as f of x is equals to x squared minus 2x minus 8, but this is not the standard format. Now I've put some values here. Usually it says y is equals to ax squared plus bx plus c. So when I check, I see my x squared is here, I see my x here is here, and I see my c. My c is my constant, is negative 8. But what do we know about c? Something is very special about c. C is the constant, at the same time c is the y-intercept of the graph. A is the coefficient of x squared. This tells us about the shape of the curve. It tells us that our curve is actually facing up like this or is facing down like this. So, do we have A here? Yes, we have A here, but A is 1. We cannot see it because it's 1. So, mathematically, we must know that there is 1 here. But is it positive or is negative? It is positive. So, if A is positive, our graph must look like this. If A is positive. If A is negative, our graph is facing down. This was just the basic background of a quadratic function. Remember, last time we spoke about linear function, which looks like this one, which says y is equals to mx plus c. On the previous video that I've done, we were talking about the linear function, where we say that c is the constant and it's also the y-intercept of the graph. So do we have something in common? C is the y-intercept here on the quadratic function, and also c is the y-intercept here in the linear function. Then we say m determines whether the graph is facing up or is facing down. When a is positive, the graph is facing up. When a is negative, the graph is facing down. So here, we don't talk about a, but we talk about m, the gradient. What does the gradient tell us? The gradient tells us if the graph, let us say m is positive, our graph is going up, and if m is negative, our graph is going down, like this. So do you see there is a relationship between m tells us about the slope of the graph, and then a tells us about the shape of the curve, where it's facing up or down. I think now we have at least a foundation of what is happening. So now I want to focus on drawing the graph of a quadratic function. So students, you must know f of x means y, always. F of x means y. G of x means y. So as I said, the standard format is saying y is equals to ax squared plus bx plus c. And then here, g of x means y. G of x is y. Don't complicate things, g of x is just y. So, if you want to draw the graph of a quadratic function, actually we need three things. We need three things. What are the three things? We need y-intercept, which you already know is c. Y-intercept I said is c, which is negative 8. I said we need three things to draw the graph. Let us start with the y-intercept. Okay, the y-intercept is 8, but mathematically, to calculate it, rather than saying it's negative 8, it has got some S marks because they want to see how do you know to calculate the y-intercept. But what do you know about the y-intercept? At y-intercept, everywhere in the y-axis, because y-intercept occurs in the y-axis, and everywhere in the y-axis, x is what? 0. X is 0. I told you this is our y, this is our x. Everywhere here, x is 0. Everywhere here, x is 0. And everywhere here, y is 0. I spoke about it in the previous video. If you don't really understand it again, you can go back and check. Alright? Y-intercept in the y-axis, x is 0. And then, so now we're going to put what? 0 in x, because x is 0 on the y-axis. And now we're looking for the y-intercept. So we're going to look for f of 0, because x is 0. So where does x equal 0? 0 squared minus 2. Where does x equal 0? Minus 8. So, meaning that f of 0 is giving us what? It's giving us negative 8. That's why we say that the y-intercept is always the same. It's always negative 8. Because whenever we put zeros here, we are remaining with what? We are remaining with 6. Which is our y-intercept. I said we need 3 things to draw the graph of a quadratic function or a parabolic function. So now we're done with the first thing, y-intercept. Now we're going to the second thing, x-intercept. X-intercept. What is happening in x-intercept? Y is equal to 0. Because x-intercept or x-intercept, let me put s here because it's not one intercept. It can be one, but most of the times it will be 2. But we'll make another video where we talk about the conditions where we find that we will have one intercept. But usually in quadratic we have 2. But it doesn't mean that we cannot have one. We can have one and we can have 0 intercepts. That is highly possible in the quadratic function. But normally we'll be dealing with a quadratic function that has got 2 x-intercepts. And then we're going to talk about those that have one intercept. So, as we know, everywhere in the x-axis, y is equal to 0. And the x-intercepts are happening on top of the x-axis, where y is equal to 0. So, what we're going to do, y is equal to 0. I like to write it like saying x squared minus 2x minus 8 is equal to 0, like this. So, how do we find the x-intercepts? We find the x-intercepts by simply factorization. How do we find x-intercepts? We find x-intercepts by simply factorization. How can we factorize them? We are going to open 2 brackets. Because this is a quadratic, we are going to have x here and we are going to have x here. This is not the only way to find the x-intercepts. We can find the x-intercepts by using the quadratic formula. So now this is just a basic introduction to the quadratic function or parabolic function, meaning that we are going to have more challenging problems, more techniques that we're going to use to solve and find the x-intercepts, and we're going to talk about shapes and all those things. But today we're not dwelling deeper into complicated things, just generally how to draw the graph of a quadratic function. So now to find our x-intercepts, we are going to factorize the quadratic equation. Meaning that we are going to look for 2 numbers, which when we multiply those 2 numbers, we get negative 8. But when we add those 2 numbers, we get negative 2. You see, when we multiply them, we get C, but when we add them, we get what? We get B. So which are the 2 numbers which when we multiply, we get negative 8, but when we add them, we get negative 2. In my right mind, I see negative 4. When I see negative 4, 8, which is our C. So when I add those two, when I add, okay, negative 4 plus 2, I get my answer as negative 2. Meaning that those two numbers which when we multiply, we're going to get negative 8, but when we add them, we're going to get negative 2. Is negative 4 and positive 2. So we're going to have negative 4 and positive 2. So this is actually our fractions. So now we're going to solve these two brackets. Each bracket we're going to equate it to 0, as you know. We're going to say x minus 4 is equal to 0, or x plus 2 is equal to 0. And then we need x. We're looking for x. Because we're looking for x intercepts. X is equal to 4 is jumping to the other side, it's changing sign from negative to positive. Or x is equal to 2 is changing sign. Because it's jumping, now we're bringing 2 to the other side, to the right side. And then since it's positive, it will become negative 2. Now we are done if the y-intercept and also the x-intercepts. Now the third last thing that we need to look at is the turning point. Because the graph of a quadratic function or a parabolic function, as I showed you, I say it looks like this or it looks like this. What is the turning point? The turning point is the point where the graph is turning. Look, now the graph is coming like this, coming like this. There is a point where everything starts changing, and then the graph now is coming up. Or the graph was coming up, but there was a point. There was a point where the graph changed direction. From this point now, it's starting to come down. Meaning that there's a point where the graph is starting to change direction. So we need to know that point, because we need it as we draw our curve. So how do we find the turning point? How do we find the turning point? How do you find the turning point of a quadratic or a parabolic function? There's a simple formula which says that, alright, for turning point, we have a formula that gives us the x-coordinate of the turning point. It doesn't give us the turning point. It gives us the x-coordinate of the turning point. So we are going to use the x-coordinate of the turning point, put it in the function to find the y-coordinate. Because a point must have x and y values. So a turning point must tell us where it is in terms of x and where it is in terms of y. But this formula that I'm going to write here, it gives us the x-coordinate of the turning point, meaning that it is x is equal to minus b over 2a. This is the formula that we are using to find the x-coordinate of the turning point, which is, we are looking at b. But look, we have a negative here. So we put negative. What is our b? Remember, our b, in terms of quadratic formula, in terms of quadratic format, our b is negative 2 here. Our b is negative 2. So look, we have negative already in the formula for finding the x-coordinate of the turning point. And our b is also negative. So we cannot say negative 2. No. Mathematically, you cannot have two sides facing each other without a bracket. So we're going to put a bracket like this, because we have negative and also b is negative there. So over 2. What is our a? What is our a? Our a is 1 here. Alright. So what is this giving us? Negative and negative, they give us a positive. So I now going to have a positive 2 over 2 times 1. It's just 2. And then we have 1. Meaning that the x-coordinate of the turning point is 1. But what about the y-coordinate of the turning point? To find the y-coordinate of the turning point, we must go to the original function of the graph to find the y-coordinate of the turning point. Because, as I said, in the graph, what is the function? The function is the relationship between x and y. Meaning that if we have the complete function, if we know one point of x, we can find the corresponding of y. Or if we have y of that function, we can find the corresponding x of that function using the what? Using the equation or the function of that graph. So now we know a point that where the graph is turning, according to the turning point formula, the graph is turning corresponding to x and y. But what is y? We don't know why. But function is the relationship between x and y, meaning that if we have one of x or y, we can find the other. Now we have x. Let us find y. Now we are going to put x here to find y. So now we're going to look for f of 1. F of 1. So now where there is x, we put 1 because our x is 1. Now we want to find y. We say 1 squared minus 2. Where there is x, we put 1. Minus 8. Now, what is 1 squared? It's 1. Negative 2 times 1 is negative 2. And then we have negative 8. What is 1 minus 2? 1 minus 2 is minus 1. Minus 1 minus 8 is minus 9. Are we correct? And then we have minus 9. Meaning that our turning point, our TP, turning point, x coordinate is 1, but y coordinate is minus 9. So, what about the x-intercept? X-intercept, x is 4. X is what? X is 4. But we know everywhere in the x, y is 0. And then another x-intercept is negative 2. But we know that everywhere at the x-axis, y is 0. Look, and now we managed to find what? Also the y-intercept, which is negative 8. But x in y is 0 always. But there, in the y-intercept, x is always 0. So now we managed to find our y-intercept, we managed to find our x-intercept, which is 4 and 0, 2 and 0, negative 2 and 0, and then we managed to find the turning point using the turning point formula to find the x-coordinate, which is 1, and then we use our function to substitute and find the y coordinate of the turning point, which is negative 9. So now I said we need 3 things to draw the graph, and we have 3 things now. We have the y-intercept, we have the x-intercept, and we have the turning point. What is left is to plot the graph. We have y-axis, we have the x-axis, we have the origin here, 0, 0. Alright, let us start with our y-intercept. Our y-intercept is at negative 8. Y-intercept, y. This is our y. This is our y. Where do you find y negative? Because we have negative 8. Y is negative from 0 going down. From 0 going up is positive. So now we're not interested in this part, we're interested in finding negative 8 down here. So somewhere we're going to have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Negative 8 is somewhere here. But x here is 0, y is negative 8. Exactly at this point. And what else? We have our x-intercepts. What are our x-intercepts? Our x-intercepts we have 4. And then where is x positive? From the origin going to the right, x is positive. 1, 2, 3, 4. Somewhere here. 4, but y is 0 at this point. And then negative 2. Where is x negative? From 0, the origin, go to the left. Okay, negative 1, negative 2. Somewhere here. Negative 2, but y is 0 here. You must know. Now, what is our turning point? Our turning point according to x is positive 1, meaning that it's somewhere here, positive 1, but what about y? In terms of y, it's negative 9. It's negative 9. Where is negative 9? Negative 9 is somewhere here, because we're at negative 8. Negative 9, I'm sure, is somewhere here. Somewhere here. Somewhere here. So, we have negative 8 in terms of y, and we have 1 in terms of x. So, these things are going to meet somewhere here. Somewhere here. Somewhere here, where x is 1 and y is negative 9, somewhere here. So, how is our graph going to look like? Our graph is going to look like this. The 4 is so close. Let me put the 4 here. So you see, this is not a perfect curve, but I'm sure everyone can see what I'm trying to do here. So our graph is looking like this. As I told you, if our A is positive, like as you can see, it's 1 here. It's not negative x. It's not negative x, but it's x. That's x. Meaning that I told you that when it is positive, our graph is going to look like this. But if A is negative, our graph is going to face down. But if our graph is facing up, meaning that we did the correct thing by saying that A is positive and our graph is going up. So we have our x-intercept, 2 of them, where the graph is cutting the x, and we have our y-intercept, where the graph is cutting the y, and we have a turning point where the graph is doing what? Where the graph is turning from going down to going up. It's starting to turn here. In terms of x is 1 and in terms of y is negative 9. So I hope here we're clear, and I think we are done now with our quadratic function. So this is how we draw our quadratic function. We need 3 things. We need the y-intercept, which is the c. We need the x-intercept, which we find by factorizing or solving using quadratic formula. And then we need a turning point, which we use the x-coordinate formula for finding the turning point. If we find the x-coordinate of the turning point, we use that x-coordinate to put it in our original function to find the y-coordinate of the turning point. So by having these 3, we are able to draw our graph for the quadratic function. That's what I was having for today. Thank you, students. Please like my video and also subscribe so that whenever I drop a video, you get notified, and others who are still coming will see the video appearing on top if it is liked by majority. I thank you very much. Enjoy your day.